Hi Algebra 1. Today we're going to discuss our fourth method of solving quadratics, and it's by a method called completing the square. Pay close attention to this one because this one has other applications other than just solving quadratics, so it becomes helpful later on in Algebra 2. In your journals, you will find the steps on how to complete the square. Completing the square itself, like the process of completing the square, creates what we call a perfect square trinomial. And you've dealt with these before. A perfect square trinomial, an example of one, would be x squared plus 6x plus 9. The benefit to when you factor a perfect square trinomial is that they factor into two of the exact same thing. So you could write it as one quantity squared. And then that has benefits because to get rid of that square, you would just square root it. So we want perfect square trinomials so that we can write them as one binomial squared and then square root it. So what you have here, these steps create a perfect square trinomial. So if you look through these, the first thing you're going to do is you're going to take half of b, and b is your coefficient on your x. So you're going to take half of the coefficient on x, you're going to square it, and you're going to add it to the end. Okay? So we're going to practice this. Half of b, square it, and you're going to add it to the end. So we're going to look at the first extra practice and practice this skill. So looking at the extra practice, you will notice these all have two terms. Essentially, they have the first and the second term, and they're missing the third term. And when I say that, I mean because we're going to look at a quadratic being ax squared plus bx plus c. So these kind of all have the first two terms and they're missing that c, that constant. Okay. The other thing to notice on all of these is that their leading coefficient is just a 1x squared, and that becomes really important. So the fact that these are all a 1x squared, we can go through our steps. So the first step was to take half of b. So b here is 12. Half of 12 is 6, and then you're going to square it, and it's 36. So that becomes my perfect square trinomial. So completing the square just means to put a plus 36 on the end. That is completing the square. You made a perfect square trinomial. Then it says factor it, okay, and I'm going to go kind of quick through this factoring because we've factored before. Okay, so you're going to do x and x and then decide what makes 36, and that also would make 12, and that would be 6 and 6, and they would both be positive. You really, though, do want to try to get in the habit of writing it as 1 squared. Now, a little tip I'll show you, only when it's a perfect square trinomial with a leading coefficient of 1, that this term right here is exactly half of this term in the middle, including the sign, and they get to be easier to factor if you realize that. So let's look at number 2. Okay, you have 1 as your leading coefficient. You're going to take half of b, which does happen to be a negative 7, but when you square it, turns into a positive 49. So you're going to have plus 49. That is your completing the square. Then you're going to factor it, and it's going to factor into x minus 7 squared, because that's exactly half of that middle term. And if you work this out, if you work out x minus 7 times x minus 7, you'll see that it foils out to be this up here. All right, why don't you pause and see if you can finish these. Now I stopped short of finishing because I want to look at them when they have an odd b. So hopefully for 3 and 4 you can check those and you did well. So when you get to 5, you have half of 7. Now, your gut instinct might be to say half of 7 is 3.5. Yes, it is. But I'm going to tell you that's not how you're going to want to write it. Half of 7, you really need to write as 7 halves, right? You're just multiplying straight across. Because when you square it, you're going to square the top, square the bottom. That's one of your exponent rules. You get 49 fourths. That's what you're adding to both sides is 49 fourths. That is so much easier to do than if you asked me to square 3.5, because I'd be like 3.5 times 3.5, I have to go back and remember how I multiplied in the 3rd grade. So if you will work it out as a fraction, it is so much easier, I promise, even if you hate fractions. Then when you go to factor it, so that's your completing the square. Then when you factor it, x, and then it's exactly half of this, which is 7/2. And there you go, now it's factored. So let's look at 6. What's half of 11? Half of 11 is 11/2. And then you square it, which just means you're going to square the top and you're going to square the bottom. So it's 121/4. And then that is your completed square. To factor it, x, and then you're going to have exactly half of this, which is 11/2. And then it's factored. All right, that's the process of completing the square. We're now going to tie that into solving. So you're going to go back a page in your notes and we're going to write a list of steps. So you will find that completing the square is very procedural. Every time you do this list of steps, and it never varies. This is the same thing every time. So on page 293 of your journal, you have a section for notes, and I want you to write this list. Okay? The first thing you're always going to make sure is that your x squared does not have a coefficient. You want it to be 1x squared. So the first thing you're going to do is you're going to remove any coefficients on x squared. Up next, you're going to move c to the right-hand side. So c is your constant, so you're going to add or subtract that over to the right-hand side. Then you're going to do your completing the square step, which is what we were just practicing. Right? You take half of b, you square it, and you're going to add it to both sides instead of just the one side like we were just doing, because we're now going to be working with an equation. After that, you're going to factor the left-hand side and simplify the right-hand side. And then you finish it actually like you're solving with square roots, and you square root both sides and then just simplify after that. So make sure you have this list written down, because every time you're going to go through this list and complete these exact same steps. So we're going to do like 3 progressions through difficulty and problem. So here's the first step. Okay, step number 1 was make sure you had a 1x squared, and these all have a 1x squared. Okay, step 2 was move the constant from the left side to the right side. That's already been done for you. Notice your constant is on the right side already by itself. So you're actually ready for step 3, which was completing the square. Now before you do that, I would actually rewrite this and leave a gap. Okay, you're going to rewrite it, you're going to leave a gap where that constant should be on the left. So you're completing the square step. You're going to take half of b, so half of -8 is -4. You can drop the negative if you want to. You're going to square -4, so it becomes +16, and you're going to add it to both sides, because hopefully some point you learned whatever you do to one side, you have to do to the other. You just completed the square. You haven't solved by completing the square, but you completed the square. The left-hand side is now a perfect square trinomial. So that means we can factor it, and it's going to be x minus 4 squared, because that's exactly half of that middle number. And if at any point you don't believe me or you don't trust yourself, work that out, FOIL that out, and make sure you get to what you were just at, which would be that right there. Make sure that that works. All right, make my minus sign look like minus sign here. There we go. So that is factoring the left, simplify the right. The next step, so I think that's step 4. Step 5 was to square root both sides. That's going to leave you with x minus 4, because your square root and your square are going to cancel. Remember, when we square root and we're solving, we're always going to add a plus or minus. The square root of 1 is 1. And then you're going to finish solving. So we're going to add the 4. You probably want to write that in the front to begin with. And then you're going to look at your 2 cases. You're going to say what's 4 plus 1. And that's going to be 5. And then you're going to say what's 4 minus 1. And that's going to be 3. Okay, if you want to check, you should be able to put 5 and 3 back up here in the original problem, and they'll both work. All right, so let's look at number 8, and then I'm going to leave you number 9. Okay, so step 1 and 2 are already done because you're having 1x squared all by itself and your constants on the other side. But I would really caution you, though, to go ahead and leave a gap in there. Then you're going to complete your square. So b is 2. What is half of 2? It's 1. 1 squared is 1. So you're going to add 1 to both sides. You're going to factor the left-hand side. This is going to be x plus 1 because 1 is half of 2 equals 4. You're going to square root both sides. That's going to leave you with x plus 1 equals, you always add a plus or minus, and the square root of 4 is 2. Then we're going to move the 1 over. You're going to write it in the front to begin with. That's a plus or minus there in the middle, in case you wondered what that symbol was. All right, then you're going to do your two cases. What's negative 1 plus 2? Positive 1. And negative 1 minus 2 is negative 3. And again, if you want to check, you should be able to put those back into the original problem and see that they work. So I want you to try 9 before we move on to the next step. All right, you might have realized this one was a little more difficult because you had an odd b. So the first thing, hopefully you wrote it and you left a gap, which would be here. Then you're going to take half of 7, which is 7 halves. You square it, which means you square the top, square the bottom, you get 49 fourths. You're going to add 49 fourths to both sides. I really caution you to keep it as an improper fraction because your math will actually work out really nice. You won't ever need a calculator. All right, so I factored the left because I took exactly half of the middle. I can do that because this is a perfect square trinomial with a leading coefficient of 1. That's why that works. I went ahead over here and made common denominators so I could add, and I got 169 fourths. I square rooted both sides, which knocked out the square on the left. I remembered to add the plus or minus to the right, and I square rooted the top and square rooted the bottom, so I get 13 halves. So if you've left everything as improper fractions, 99.5% of the time, you actually end up with common denominators already. It works out really nicely. So you're going to subtract the 7 halves over, and I wrote negative 7 halves plus or minus 13 halves. And then I did negative 7 plus 13, which would be 6 halves, which is 3. Negative 7 minus 13 was negative 20 halves, which is negative 10. Okay, so we're going to move on to the next step, which is C is going to be on the left, and we're just going to have to move it to the right. All right, on these we can still skip step 1 because these are all already 1x squared. So step 2 is to move your constant to the right-hand side. When you do that, you're going to leave a gap. Now, can you do these problems without leaving a gap? Yeah, but it's a whole lot easier if you leave that gap in there. All right, so step 2, move C to the right-hand side. Step 3 is you're completing the square. So you're going to take half of b, which is either 6 or negative 6. They both work. You're going to square it. It becomes a positive 36, and you're going to add it to both sides. And you're just following these same steps again. You're going to factor the left-hand side. Factors into x minus 6, because that's exactly half of your middle term, equals 27. And then you're going to square root both sides. So you're going to have x minus 6 equals a plus or minus. Now, there's not a perfect square root of 27, so let's practice our simplifying of radicals, which we talked about in 9.1 if you need to refer back to that. 9 and 3 both go into 27, so this becomes 3 square root of 3. You're going to add the 6 over. Now, for me, if you were doing a book assignment, I actually want you to leave your answer exactly like that. That is the exact answer. 6 plus or minus 3 square root of 3. In the case of having to submit an answer online, though, it might ask you to put it in decimal form. So to put it in decimal form, I have my calculator out, and I'm going to do 6 plus 3 square root of 3. So my calculator is 6 plus 3 square root of 3. I'm going to go ahead and round to 2 decimal places. So that gives me 11.20. It's actually 11.196, but you've got to look at that 6, which would round the 9 up. And then I'm going to do 6 minus 3, square root of 3, and that gives me 0.80. And then those would be my two answers rounded to 2 decimal places. All right, so the only thing that's different about this set of examples is just that the first step, which actually the second step in that list I gave you, that you need to move the constant over to the other side. So I'd really like for you to pause and see if you can do these, and then we'll head to the next step, which is the harder ones. All right, so just to go through the steps here real quick, the first step, which is actually the second step from the list, move your constant to the other side, to the right side, leave that gap in there. Then you're going to take half a b, you're going to square it, you're going to add it to both sides. You're going to factor the left because it now factors into 1 binomial squared. You're going to simplify the right. You're going to square root both sides to get rid of your square. Okay, you're going to add a plus or minus to the right. If the square root of 59 simplified, I would have simplified it, but I don't believe it does. You're going to subtract the 7 over to get x by itself, and you have negative 7 plus or minus square root of 59. If you're returning an answer into me, I want it exactly like that. If you have to give it in decimal form, though, I just went to my calculator and entered negative 7 plus the square root of 59 and negative 7 minus the square root of 59 and got these 2 decimals. I rounded to 2 decimal places. All right, and hopefully you can follow the same steps on 15. So let's look at the harder stuff, shall we? So unfortunately, your leading coefficient is not always 1. It is ideal when it's 1, but it's not always 1. So let's look at 16 here, and this is not going to be fun and friendly at all, but we will make it through it. So your very first step always is to make sure your leading coefficient's 1. My leading coefficient is 10. How do you get rid of the 10? You divide by it, and you divide everything by it. You don't want decimals. Let me say that again. You do not want decimals. You want to leave them as fractions because they will work out nicer. You especially don't want any rounded decimals because you would then veer away from the correct answer. So this is going to be x squared minus 13 tenths x minus 9 tenths equals 0. Okay, so all I did was simplify there. Here, I'll clean up some of my handwriting. So then that was step 1. So step 2, I'm going to move my constant to the right-hand side. So I'm going to add over 9 tenths. So I have x squared minus 13 tenths x. You're going to leave a gap, equals 9 tenths. Then you're completing the square. So you're going to take half, I'm going to write it up here at the top, half of 13 tenths is 13 twentieths. You're going to square it. That is 169 over 400. Okay, that is what you're adding to both sides, 169 over 400. You are then going to factor the left-hand side, keeping in mind it's exactly half of this, which we actually already did up here. So that is x minus 13 twentieths squared. Now, to add these together, I'm going to need a common denominator. So if I multiply by 40, that should be 360 plus 169. That's going to give us 529 over 400. So the next thing we're going to do, we're going to square root both sides, which is going to give us x minus 13 twentieths. And then we're going to square root the top and square root the bottom. So I'm going to check to see the square root of 529. I just did my calculator, and it's 23. The square root of 400 is 20, and you always need to remember to put your plus or minus. We're going to add 13 twentieths to both sides. So x is going to be 13 twentieths plus or minus 23 twentieths. So if we do both of those cases, 13/20 plus 23/20 should be 36/20, which looks to be 18/10 or 9/5. And then 13/20 minus 23/20 would be -10/20, which is going to be -1/2. And in decimal form, this one up here is 1.8, and then this one is -0.5. All right, so I know that took up a lot of our space there. So instead of trying to make you fit on another one, I'm just going to reiterate the directions real quick. So step 1 is make sure your leading coefficient's a 1, which might mean that you have to divide to get there. So on 17, you would divide everything by 3. On 18, you divide everything by 12. And you really want to leave them as fractions because it works out so nicely with your square root. So you divided everything by the leading coefficient. You moved your constant to the right-hand side. You took half of b, squared it, added it to both sides, factored the left, simplified the right, square rooted both, made sure you put your plus or minus on the right, moved your number over from the left, and then just simplified to your answers. I'll go ahead and give you the decimal forms of your answers for 17. X, I have the approximate answers. It's about that's a 0.2 and a -2.2. And for 18, it's about -0.2 and then a 0.9 if you want to do them and check and see what you get for your answers. So I'll leave you at that because I know this was a little longer one, but there's a lot of steps here and you got to know them, okay? Let me know if you have any questions, and I'll see you later.